Okay, so let's do some practice problems, and we're going to get pretty involved with this. You'll see x squared minus 25. And we want to factor this completely. So the first things we want to look out for is the first term a perfect square? Is x squared a perfect square? It is. Is 25 a perfect square? It is. It's 5 times 5. So how would this factor?
X plus 5 times x minus 5.
Now, raise your hand if you thought the same thing. That's what you do. Okay. It's really just recognizing the pattern. Once you recognize the pattern, it goes quickly. And the x term doesn't even have to be the first term. What if I gave you something like this? Again, 49 is a perfect square. 7 times 7. X squared is a perfect square. X times x. So how would I break this up? What would go first? Well, I don't see x though.
Negative x.
No, what's first here? Yeah, 49, so it would have to be 7. Now, it doesn't matter on this one, right? Because we can interchange them. Well, it doesn't matter in this term because addition is commutative. 7 plus x is the same as x plus 7. In the second term, it does matter. It has to be 7 because what are we doing in this one? We're not adding, we're subtracting. So it has to be in this form. If the number term comes first and it's a perfect square, it has to come first in your binomials. Okay? So normally, we've been doing a lot of stuff where it didn't matter because it was just multiplying or adding and it's commutative, but here it does matter. So let me give you this one. Okay, go ahead and factor that into two binomials. What's that going to be? They're both perfect squares. 121 is a perfect square. X squared is a perfect square. What would come first? 11. And what doesn't matter is normally I've been writing the plus binomial first. I could put the minus binomial here and the plus binomial there. Because we're multiplying these. The order doesn't matter. But what does matter is the order of the numbers and the variables. So if you thought this or something like this, good job. Okay? Now, for the next one, I really want you to focus and think about it. The following is a difference of squares. X to the fourth minus 16 is still a difference of squares, believe it or not. Anytime I have an even exponent, it's a perfect square. Think about this. We've talked about it when we first started talking about powers. What was it, like a month ago? What's the square root of x to the fourth?
X squared.
X squared, right? X squared times x squared is x to the fourth. What's the square root of x to the sixth? X to the third. What are we doing each time? We're dividing by 2. What's the square root of x to the 10? X to the 5. Just divide it in half. Okay? So 16 is a perfect square, right? It's 4 times 4. So how would we write our two binomials? What would go here? X to the second. Okay. Ooh, okay. I just thought about something. What would go here? Plus or a minus, or does it matter? It doesn't matter. So, and then square root of 16, of course, is to the fourth. All right. Now, look what we have. X to the fourth. I'm sorry, x squared plus 4. X squared minus 4. Look at it carefully. Am I done factoring? I think I'm done factoring here. Am I done factoring here? Oh, some people are shaking their heads now. Can I still factor this? Can I still break this one down? Not the first one, because it's got a plus. Can I still use this pattern on this one? Yeah. So that's going to happen a lot on today's assignment. You're going to be done factoring, and you're going to say, wait a minute, this is still a difference of squares. So it's going to be this stays the same because I really can't factor this. But this breaks down into x minus 2 and x, or x plus 2 and x minus 2. Okay, if you break something down and you still have a difference of squares, you can still break it down. So this is actually this. Okay. All right. Number 5. Um, so I want you to focus that on this one. X to the fourth minus 81. So try this one. X to the fourth minus 81. Okay, we could follow this model, right? Same thing we did here. And we would get x squared plus 9, x squared minus 9. Got that? Obviously, with a plus sign, you can't factor anymore. Can I still factor this way? Yes. So this continues to factor into x squared plus 9, and then x plus 3, x minus 3. All right. Any questions? Okay. Number 6. Hmm. Ah, messed it up. You don't want to go there yet. Okay, let's start over. Let's do x to the sixth minus 25. This is still a difference of squares because something times itself equals x to the sixth, x to the 3. And obviously, 5 times 5 is 25. So this would break down into these two factors. X to the 3, a plus and a minus, and what goes behind each of them? What would go here and here? 5. Okay, and it's always, remember, with the minus sign, it's always, can we factor this more like we did on these others? Is x to the third a perfect square? No, because it's odd. Odd ones aren't perfect squares. Is 5 a perfect square? So the moment either of those is not a perfect square, then no, that's as much as you can factor. So x to the 6 minus 25, this is as much as we can break it down. Okay? Any questions? All right? Okay. So I want you to try this one. 6. X to the 4 minus 1. X to the 4 minus 1. Yes. Oh, yes. Thank you. It's number 7. I was looking at the one above, forgetting we've done. Thank you. So check in with your table partner after you're done and make sure that you factored everything you can. Okay? Okay. So this is what I got. First, x squared, x to the 4th minus 1 is x squared plus 1, x squared minus 1. But then x squared minus 1 is a difference of squares. So that would break down this way. Any questions? All right. Number 8. Today it's just examples so you can see the pattern. And I'm going to forewarn you, you can break this down further after the first thing you break down. Okay. 81 minus x to the 8th. Think about what you can break, how you can break this up into difference of squares. Just following the pattern of that rule that we learned. What would this break up into? What would I have first? 9. What would I have behind the plus and the minus? X to the 4th. That one doesn't look very good, but it's x to the 4th. Now, which of these can I break down further? The plus or the minus? Minus can still break down. 9 is a perfect square, and x to the 4th is a perfect square. So I could still break that one up. So let me just copy this one because it's going to be part of my answer still. But this would be 3 minus x to the 2nd, or plus, I should say. I put the plus one. And this would be 3 minus x to the 2nd. Now, let's see. Because with the minus one, you got to worry is, can I still break it down? Can I still break down and factor 3 minus x squared? What do you think? Look at each term. X squared is a perfect square. We know that. Is 3 a perfect square? No. So one of those two is not a perfect square. That's as far as you can break this down. Okay? Any questions? All right. All right. We haven't had one like this. Number 9. 16x to the 8th minus 1. I didn't mean to put parentheses around it. Ignore the parentheses. Okay, this is just pattern recognition. 6x to the 8th is a perfect square, and we know 1 is a perfect square. Okay, what would go in the first term in each one? 4x to the 4th. Just take the square root of this whole thing. Square root of 16 is 4. Square root of x to the 8th is x to the 4th. What would go here? 1. And let's take a look. Obviously, this won't break down anymore. Can I break this one down further? Yeah, 4 is a perfect square, x to the 4th is a perfect square, and 1 is. So 4x to the 4th plus 1, and then we have 2x minus, or plus 1, let's make it plus. Oh, it's squared too, sorry. So 4x to the 4th square root is 2x squared, so there it is. 1, its square root is 1. So now let's look at this last one. Can I break this one down? Some people are shaking your heads no. Why? What's preventing me from breaking this down further? Yes. Yeah, 2 is a prime number. It's not a perfect square. So because of that 2, if it didn't have the 2, yeah, we could break it down. X plus 1, x minus 1. But that 2 keeps us from doing it. Okay? The last ones we're going to do are the ones where we factor. You know what? Yeah, I think that's enough. I've thrown a lot at you. I'm going to change this a little bit, but give me one moment and then we'll get to work. We'll stop it right there, but I got to change the assignment a little bit. Okay?